Now, whenever you see this where it says 2 times x, what does that mean when you multiply something by 2? What are you doing? Doubling it. So you should know that, okay, this says cosine 2x. First of all, we have two different identities, right? We have cosine and sine. And this one is a double angle. So we have to do a substitution. Now with cosine, we have 3 options. But because we have a sine, it would make sense to use this one. Actually, this is the only one we can use. Well, maybe not the only one. But that would be the smartest one to use. So what I'm going to do is substitute this cosine 2x. I'm going to put 1 minus 2 sine squared. And that equals negative sine squared. And then I always like to do my substitution. I'm going to say u equals sine. So I'm going to write this as 1 minus 2 u squared equals negative u squared. All right, so I want you to try to solve that for you. How would you solve that equation? And doing that substitution again is always optional. So I'm going to add that 2u squared over. Which will give me 1 equals what? U squared. And then here's the hard part. When you take the square root of 1, you get 2 answers. And I think that's the thing that most, at least on the last test, there was a question where it was like, name the mistake. And a lot of people said there was no mistake, and there was a mistake. The mistake is that when you take the square root, it's positive and negative. And so the square root of positive 1 is not just 1, it's also negative 1. So u equals 1, and also u equals negative 1. But we know that u is actually sine. So at this point, I'm going to put it back in there. Go ahead, look on your unit circle and tell me where is sine equal to 1 and negative 1. Here, let me pull it up a little bit. Where is sine equal to 1 and negative 1? Between, and the interval said, let me zoom back out, between 0 and 2 pi. So sine is your y value. So you should have that x equals pi over 2 and 3 pi over 2. All right, any questions about that? So when you see an equation with a double angle, do a substitution. So maybe that's something you want to write in your notes. So if you see a sine 2x or a cosine 2x in an equation, you have to do a substitution. Cosine, you have 3 options. Sine and tangent, there's only 1. All right, so now let's start talking about half angles. Oh, wait. Okay, let's go ahead and solve this one. Let's copy this down real quick. Okay, yeah, so we have 2 equations to solve. Oh, we got another double angle. We got to figure out which one to use. So we got 3 options. I'm going to label them A, B, and C. We got A, B, C. Actually, I'm going to number it 1, 2, 3. Show me with your fingers. If you were taking this, if you saw this on the test, which one would you choose? 1, 2, or 3? I will use 3. The reason why I would use 3 is why. Why do you think I picked 3? What do you notice about 3?
It's got only cosine.
Yeah, it has only cosine. So if I'm looking here, you could just put that on my desk, yeah. If I'm looking at this one, I'm noticing I have a cosine. So why would I introduce sine if I don't have to? So we're going to stick with this one and just use the cosine. So in place of this, I'm going to put this. So I'm rewriting that equation and putting what I have underlined in green is what I'm going to put there. So I have cosine squared minus, and then I'm going to put my substitution in, which is 2 cosine squared x minus 1. Now, because it's behind a negative, I am going to put this in parentheses. That equals 1/2. Good morning. All right, so now we need to distribute that negative. These are like terms. Did you want me to do the U substitution? Is that helpful if I rewrite it with the letter U? Or no? Or does it not matter? Does it matter? Okay. All right, so I have 1 minus 2, which is -1. Or, yeah, -1 cosine squared. And then we're going to subtract the 1. And 1/2 minus 1 is -1/2. And then we're dividing by -1, which is going to give me cosine squared equals +1/2. And what do you think I'm going to do next? Square root. All right, so I'm going to actually rewrite this here. Well, I'll just write it down. So I have cosine squared x equals, so remember that I'm taking the square root of 1 over the square root of 2. That's how you square root a fraction. You have to look at numerator and denominator individually. So the square root of, I'm going to put my plus minus right here. So that gives you the cosine squared x of positive and -1 over root 2, which we cannot leave a root in our denominator. So what do you have to do? Multiply by what? Root 2. So we get that the cosine squared, or cosine, sorry, I should have took the square off at this step because it's no longer squared because I took the square root. So the cosine of x equals plus and minus root 2 over 2. So on your unit circle, tell me where is cosine, positive and negative root 2. So I'm going to try to do it without looking at the unit circle. That's all my 45 90s. So 1, 2, 3, 4, 5, 6, 7. And that would be my answers. I think the hardest part is just the algebra and solving. What you have to do to solve that. Okay, our last equation, and then we'll get into our half angles. Go ahead and copy that down. And this is a beta, which you can always change to x, which I think I will, because I don't know if I feel like making a fancy b right now. So we're going to just make that a good old x and keep it simple. But again, whenever you see this means double angle. You have to do a substitution. There's only one option, though, for sine. There's only one option for sine. We don't have 3 choices. We only got one. So let's start by doing our substitution. You're going to substitute this. If you look at your pink sheet, this is what the sine double angle equals. So I'll give you a minute to put in that substitution, and you're going to take out the GCF. From there, it should be pretty easy. Okay, so when I do my substitution, I have 2 sine x cosine x. And then I'm going to write the rest. All right, and from there, it should be really simple. You're going to take out your GCF, which is what? Sine. Which is going to leave you with 2 cosine x minus 1. And go ahead and set both of these equal to 0. So sine x equals 0. And 2 cosine x minus 1 equals 0. Which is going to solve and give you cosine of 1/2. So go ahead and look at your unit circle and tell me there's sine equals 0. 4 answers. So look at your unit circle and tell me where is cosine 0. Sorry, where is sine 0 and where is cosine 1/2. So sine is 0 at 0 and pi. Is that right? 0 and pi? So it wouldn't, only because, do you see how the 2 pi has the parentheses on there? So 2 pi is not included and 0 is. So you have to use the 0. Good question. I'm glad you mentioned that. So 0 and pi. All right, cosine is 1/2. I don't have my unit circle in front of me. Pi over 3 is one of them. And then what's the other one? pi over 3, and where else?
5 pi over 3.
5 pi over 3. Who agrees with those two answers? This is first period, so I'm trusting y'all. All right, so now that we have finished our equations, now let's get into, so we,
You said 5 pi over 6.
wait, what did you say? I'm sorry. What's the answers?
I said 5 pi over 3. She said 11 pi over 6.
11 pi over 6. Cosine. Wait, cosine is positive in quadrants 1 and 4. So quadrant 1 is pi over 3, and then is the 5 pi over 3? All students take, I think he says a smart trig class. All right, so is 5 pi over 3 in quadrant 4? Do we agree? Okay, do I need to get my unit circle? I could trust y'all? Okay. Trying to trust y'all now. Okay, so now let's talk about half angles. Let's go. Draw a line in the sand. Let's talk about half angles. So now we're going down our pink sheet. We talked about sum and difference. We talked about double angle. And now we're talking about half angle. So this is the third set of identities on your pink sheet. Again, you don't have to memorize this side of the paper. So keep in mind that in this case, tangent gives us 3 options. Sine and cosine, we only have 1. Tangent, we have 3. So what you're essentially asking yourself, if you're trying to figure out what the sine of 22.5 is, what angle on our unit circle is, if we take this number and multiply it by 2, what do we get? 45. So the half angle, what we're trying to figure out is the sine of 45 over 2. Because half of 45 is 22.5. So we only have one option. And notice that in order to find this, let me zoom into the identity. We have to use the cosine. Now, does everyone notice how there is a positive and negative in front of these identities? The reason why is you have to think about this. You have to say, well, first of all, what quadrant would this fall in? 22.5. On our unit circle. Show me with your finger. What quadrant is the angle 22.5? Is sine positive or negative in that quadrant? Positive. So even though it says positive or negative, we know that it is a positive answer. So when we write our identity, it's going to be positive. And then you make your square root. And it's 1 minus the cosine (45) over 2. Let me switch out my pen because this pen is a little... Okay, so what is the cosine of 45 degrees?
Pi over 2.
Huh?
Not pi over 2.
What? You threw me off a little bit with that answer. I was like, wait, is it? I was like, I don't know. Square root 2 over 2. There we go. So let's go ahead and put that in. And you don't have to keep putting that plus sign in the front. once you know it's positive, like a positive number doesn't have to have the plus sign in front. Now, if it's negative, you have to keep the negative, but the positive you don't. So we have 1 minus square root of 2 over 2 over 2. And now we're just doing a lot of fraction rules to simplify. So the first thing I'm going to do, let me use 2 different colors. So I have 2 over 2 minus the square root of 2 over 2. It's a lot of 2's, isn't it? Why do you think I rewrote this like this? Instead of a 1, why did I write it as 2 over 2? Because what do you have to have in order to subtract fractions? A common. So instead of writing it as a 1, do you agree that 2 divided by 2 is 1? So now I can bring this together and write this as a single fraction. So this is going to equal, and so I'm going to split it apart at this point. I have 2 minus, let me write it in red. So my numerator is 2 minus root 2 over 2. And that's being divided by 2. That's what's underneath my radical right now. So I'm just using different colors to show numerator is in red, denominator is in green. And then what do you have to do for dividing fractions? Keep chain flips. So I'm going to do that again. And then we go straight across, which is going to give me 2 minus root 2 all over 4. Let me zoom in and bring this up a little bit so we can all see. And I'm just showing all the steps because this is our first time doing a half angle. So now we're going to split that fraction into 2. So in my numerator, I have the square root. Yes, you can have 2 square roots in your numerator. My numerator has 2 square roots. And what is the square root of 4? 2. And that would be my final answer. Okay, so these calculators don't give you that exact answer with a half angle. And that's how you use the half angle identity. All right, let's do another one. Sine of 165. Wait 1 second. Yeah. And if you look at it, the only difference, let me zoom in here. The only difference between the sine and cosine half angle is that cosine is 1 plus and sine is 1 minus. It's the same steps. Okay. So let's do sine of 165 degrees. So the first thing I would figure out, and it's going to tell you on the test, it'll say use half angle, use sum and difference. The only thing, well, I shouldn't say that. It'll say that in most questions. Okay, so I know that what angle am I dividing in half to get 165? 330. So if you're not sure, you just add them twice, you get 330. So theta is 330. So I'm using the sign again. Now, 165 though, before I move forward, 165 would be in what quadrant? Show me with your fingers. What quadrant is 165 in? All right, is sign positive or negative in quadrant 2? Positive. So again, we're going to use the positive. So you always want to start by asking yourself that question. What quadrant is it positive or negative? You start with that. Unless you're using one of these two tangents at the bottom, notice that they don't have the plus minus in front because it'll naturally give you the right sign. But for these other 3 identities, you have to start by identifying, is it positive? You have to figure that out. All right, so we agree that sign is positive in quadrant 2, so we can move forward here. So we're going to use this identity. So we have the sine of 330 over 2 equals, and we said it was positive, and then we have 1 minus the cosine of 330 divided by 2. And from there, you're just going to simplify. So I'm going to give you a couple of minutes to try to simplify this by yourself using the steps. It's the exact same steps that we just used for the sine. You got to get a common denominator. You got to write it as one fraction. You got to do cube change flip. You got to take the square root. You got to do all that. What's the cosine of 330 though? Negative 1/2. Who got negative 1/2? For
No, never mind. That's
Okay, sorry. What's the cosine of 330? Positive? Yeah, positive root 3 over 2. Okay. Okay, I'm gonna work it out and you work it out. You can go ahead and check your answer against mine. I didn't show all the steps, but I showed most of the steps. So I started off by making it a common denominator. So my numerator, I wrote my numerator in red, so that became 2 minus root 3 over 2. Who had that? Divided by 2. That's my identity. So I divided it by 2, because that's what the identity says. It says take that, divide it by 2. So I divided it by 2. Then I did my keep, change, flip. When you multiply across, this becomes a 4. And when you take the square root of 4, you get 2. So who reached this conclusion? Who got close? It's only our second one, so. All right, we'll do one more half angle, and then we'll end there. All right, go ahead and copy this one down. So this one is in radians. So I know I have to add okay. Which can help me figure out what my angle is going to be. So for this one, I'm using 7 pi over 6. So you add 7 over 12, or you just take 7 over 12 times 2, really. You double it to figure out, okay, what would it be if I cut it in half? I think the hardest part about radians is, first of all, we got to figure out what quadrant this would be in. 7 over 12. Show me with your finger at first. Okay, I got it. I got my number. Wait, no, I don't. 12. So the first question I ask myself is that more than 1/2 or less than 1/2? 7 over 12. More. So I know I'm not in quadrant 1. So, but is this more than 1? 7 over 12 is more than 1/2, but it's less than 1, which means that we are going to land in quadrant 2. And in quadrant 2, is cosine positive or negative? Negative. So that's the fractions, and like that, those fraction rules. Fractions we got to really think about a little bit, you know. Okay, so let's hit it. So we know it's negative. So I'm using this identity, except I know I have to keep the negative. So we have negative. I'm going to make my little fraction. Except now, because I'm using cosine, it's 1 plus the cosine of 7 pi over 6 over 2. All right, take a minute and simplify it. Go to your unit circle, figure out what is the cosine of 7 pi over 6, and then do the simplification magic that you've been doing. Except this time we have to remember to keep that negative in front of my final answer. So I'll give you a minute to simplify that down. What is the cosine of 7 pi over 6?
Negative 3 squared over 2.
Negative root 3 over 2? Who got negative root 3 over 2? For the cosine of 7 pi over 6. All right. So we are gonna work out a few more questions tomorrow. Tomorrow's Zoom is like 20 minutes, 20, something like that. I'm gonna work out some more questions. Please check Canvas for the due date for homework 11, because I don't remember. Can somebody check real quick and let me know? What did I say the due date was for homework 11? I'm sorry. Yes. There's a modified schedule for tomorrow, I think like.
It's Friday through Wednesday.
Wednesday. Okay, I'm gonna move it to Thursday. I'll change it. Oh, you're done? Okay. Great job. I think you could really do it though, honestly. We might keep it Wednesday, you know you get an extra day to turn it in. But this homework 11 is double